So today we are doing a very important topic. Obviously, about like 30% questions from your exam is going to be from this topic, which means this is highly important. Okay, so let's focus on this. So first of all, we need to understand that we got two different lenses, right? We got a converging lens and a diverging lens. Converging lens is sometimes also called as convex lens, and diverging is called concave. And because it looks like a cave to me, that's why I just remember that it's called concave. Okay, so if you want to do this as well, you can. Anyway, so speaking of this, then we have like when you're drawing waves. So on a converging lens, first let's draw waves. So why it is called converging lens? Because from the center, every lens would let waves go straight, like light go straight like this. But then obviously when the light comes from this, because of refraction and change in speed, there would be one single point which is called the principal focus or focal point, where all these waves would converge like this. Okay, so that would what converging lens does. And then for diverging ones, obviously from the center the rays are going to go just straight, but then from a single point they're just going to go away like that. And that is because of the refraction as well that we have done previously. So diverging means it is going to spread it, and converging means that it is going to bring all those waves at a single point. All right, I hope you guys understand this. Let me know if you have a question here. No. So then what you're going to do is, generally when you look at any converging lens, in our case only converging lens diagrams are going to be there, so you don't have to worry about that. The diverging ones, so you just need to remember 2-3 things. First of all, you're going to look at that at the center of the lens, it is called the optical center, and this is a principal axis. This is a line that just cuts the lens into half. This is called F, is the focal point where all meet, and 2F is double of that, means it's going to meet, like it's going to be double distance from F. So this F is called focal length. So focal length is very important because it tells you exactly where the focal point is, and double the focal length. For example, if it is like 4 centimeters, so 2F would be at 8 centimeters. This is just an example. All right, so you can make it, because while drawing this, 2F is very important. That's why we're just doing this, otherwise it's fine. All right, now you can just edit this on your PDF as well, and then we can go forward. Okay, now Zain Saleh, how are you? Zain, you're coming late these days. This is not fair.
So I was in class.
Okay, now going forward with this. So when you look at the diagrams that are going to come, we're going to basically do each diagram once, and then learn about properties and example of that, and then this way we can solve, and I'll teach you how to address these when the actual exam questions come, right? So the first case we're going to look at, which is our case 1 right now, is when the object is basically beyond 2f, which means we have kept object like here, beyond 2f, like this. And then the image, we'll see where it forms. So the first line you're always going to make is from the top of this arrow, because they're going to give you an arrow or something like that, to the lens. So I've just drawn a line because I just want to see where exactly the center of lens is. So that would be your first line. And then from this, you're gonna bend it towards F like this and extend it like this. Okay, so it will always go through this. So this would be your second step. And the third step would be from the same point, you're gonna take the line and then continue straight. Okay, continue straight till it meets somewhere. Now where it meets is where your image is going to form. So if you look at this right now, so you might realize that the image that is formed is exactly like between f and 2f. So image will be between f and 2f. Do you guys understand this?
Yes.
Now, from just looking at the image, you realize two things. First of all, I'll tell you, if the object is on one side of the lens and the image is formed on the other side, it means that it is a real image. Now, what exactly is a real image? Real image is basically called image that forms on the screen. All right, so whatever screen that is, could be your eye, could be a projector screen or something like that. So it's the real image. Then the other thing you guys need to remember, that it is basically inverted, as it is upside down. The arrow was up here, it is down here. The third property here is that it is diminished. Diminished is a word that is also taken as like smaller than object. So it's smaller than the original size. So it's like that. So these words, you need to remember these: diminished, inverted, real, stuff like that. So the example of this is that this is your eye, or it could be a camera, because when you take a picture from far away, an object is really far away, then obviously it looks smaller. Like buildings would look smaller to you, but as you come closer to it, obviously it's gonna get bigger and bigger. So that's how your eye perceives things. Is it clear, everyone?
Yes.
Now I just want to put one note here. I just want to emphasize note here that if they say draw a third ray, so what you're going to do is you're going to move from the same point, go through the first F on the same side like this, and then you're going to move it straight like this. Automatically it will move to this point, and that would be your third ray. That is a requirement, so I'm going to put it here. All right, with a different color. Not always they ask for it, but whenever they do, you guys should remember this. All right, is it clear? Any questions now?
No, sir.
Okay, please draw it on your PDF, and it would be best if you just need a ruler, because I put a squared page, so I guess you will be able to. Those who do not have like it printed, they can print it out later and watch the recording and do it yourself. Otherwise you will be very confused in your exam as well, so I'm sure you don't want that. Anyway, so going to the next one. So on the next page, case 2. So in case 2, we're gonna put the object exactly at 2f, okay, which means double the focal point. So this is our object right here, 2 boxes up, and then we're gonna start making the rays. So the first ray is going to be the straight one. Let's do that. And then it goes through F, obviously, like this, make an extended ray, and the next ray is going to go from the optical center straight, and you would notice that where it meets going through the optical center, it is exactly where 2f is, right here. See, so that would mean that actually the image has formed at 2f as well. You guys understand?
Yes.
Okay, now the properties of images. Can somebody tell me if it's real or virtual?
Real.
It's real because it is formed on the other side, and then obviously it is inverted. As you can see, it's upside down, but this time it is neither diminished nor magnified. It is same size, because as you can see, it is of two boxes, and that's also two boxes. Do you guys understand? So from the image, when you form in the exam, you will automatically know what to write about the size. And the example for this is the photocopier machine, because that basically prints the same thing that you scan through it. Understood? All right, please write this down, and then you're gonna go forward. Okay. Okay, so I'm then moving to the next slide. So then we're gonna look at case 3, which is when we put the object between f and 2f. Okay, somewhere, let's suppose here. Okay, and that's your object, and now we'll see where the image is formed. So first line, who's going to tell me what do I do? Go straight, or in what do I do, please?
Straight.
Straight line till the image, till the lens, and then what do we do? Yeah,
Cross to the focal point.
yeah, we got to bend it through and to the focal point like this. Very nice. And then from this point we're going to go through the optical center, and right now it's meeting somewhere here, which is wow. So now the image, as you can see, is formed right here, and it's very big as well. So it means that now the image will be formed beyond 2f, and the properties are: is it a real image?
Yes, sir.
Yes, it is a real image. Is it an inverted image?
Yes.
Yes, it is inverted, and it is magnified. Magnified is like larger than its size, but the other word the examiner is going to use this enlarged, so that has the same meaning. Don't worry about that. Now, this is, please understand that this is not, most of people say it is magnifying glass. It is not a magnifying glass. It is binoculars. Okay, magnifying glass does not create a real image. Okay, so you guys need to remember that. Now let's go forward. Okay, you can write this down, then we'll go forward. Okay, now, so going to, this was case 3, now we're going to go case 4, and now we're going to put object at f. So if I put the object at f like this, I'm intentionally make it smaller, and then if I build the rays, so I'm going to go straight, and then I'm going to go through f like this. Cool. And then I'm going to go to the optical center, and you might see now the rays are now parallel, so they never meet. That means that actually image never forms. So it basically forms into a beam of light. It doesn't really do anything. So image is not formed. All right. The example for this is like they're not going to ask you this, but I'm just going to tell you. It's the bat signal. You guys know what is a bat signal? You guys don't know what is a bat signal? That's not fair.
I know, sir.
Yeah, bat signal is the Batman signal. You guys. That's very sad. You see they project it. Yeah, so that's just a shadow, that's just a shadow, and then they put it through the lens, and that shadow is created far, far away. The image is never formed, it's just the shadow that forms. Do you understand? How cool is that? Okay, so this was by far the easiest one because we had to do nothing really. And now we're gonna go to case 5, which is the last one. In case 5, we are going to place the object before f, which means right somewhere here, and then we're going to make lines. So we go straight, we're going to go through f nicely, okay, like that, and then we're going to go through optical center. So now you might see that the lines are diverging, like they're going away. So if you're looking from here, the eye would definitely think that these lines are coming from some place far, far away, like this, okay? So this is basically what you're gonna do is you're gonna basically extrapolate it. This I'm just gonna write it right here. What I've done here is called extrapolation. So you want to extrapolate backwards, and then obviously where it meets, this is where your image is going to be formed. It's not necessarily, so it's beyond f. It could be beyond 2f as well, so it could be very large. Now the properties are, because it is forming exactly at the same side where the object was, that means that this is a virtual image. A virtual image is the image that does not form on the screen. So it forms behind the screen, before the screen, like behind the screen usually, but not exactly on the screen. So that's something wrong. And then obviously if you can see, it is upright. Upright means that it is opposite of inverted. It means it's standing the same way as the object was. It's not inverted. And the third thing is it is magnified, as you can see. And the example of this is obviously magnifying glass. Like you see A, B, if you magnify C on the glass, it would look like this, and then D, E, like that. You guys understand this?
So for some reason mine doesn't come like that.
Your doesn't come like that?
It doesn't go beyond 2f4 here too.
It's alright, but it goes back, right? Let's go back. Because my line might be a little bit different because I couldn't snap it back. That's why. Don't worry about that. Okay?
Sir?
Yes. Yes, Zainab.
Would you as an example?
Which example, sorry?
Projector. Could we say projector as an
No,
example?
no. Projector is basically a this binoculars. This projector as well. Projector basically projects the image onto a screen, so that's a real image. That's not basically behind the screen. So it cannot be it cannot be virtual, right? That so it is case 3, not case 5. Do you understand?
Okay, so the reflection in a mirror. That's an example.
Reflection in a mirror is a virtual image, yeah, but it doesn't go through lens, so we can't say anything about that. Okay. Right. Now, so I hope you guys understand how to construct everything. Now, they're not gonna ask you about a lot of things directly, but they're gonna be very clever in this. So I'm gonna show you what kind of questions you're gonna see and how to do those. For example, oh, before that, we're gonna do magnification. Sorry. So when you say something is enlarged, something is like diminished, so obviously it means it is smaller than its size or larger. How do we find magnification? So we say that linear magnification is equal to, either you can do height of an image divided by, you could say, the height of an object. That would give you that linear magnification factor. The other formula for this is, which is also used in the exam, magnification, oh my god, is basically distance of image from lens divided by distance of object from lens. So basically it would be the same. This would be the same linear magnification distances like that. All right, is that clear, everyone? So you quickly write it down, and then we'll do a question about it, so you guys have a clear understanding what I want from this. So if you look at this question, okay, please write this down first. I'm sorry. Okay, Hussein, do you understand everything? Shawez, Saleh, Smiley, all the boys in this class?
Yes, sir.
And all the girls, do you understand as well?
Yes.
Okay, good. Now, so this sort of question, it says an object is placed in front of converging lens with a focal length of 15. Which row describes the image of the object, right? So first of all, you guys need to understand something clearly here. If an object is placed in front of converging lens, focal length of 15, so anything beyond, if you look at all these things, whenever we had object behind, like behind f, so greater than the focal length, every time it would create a real image and an inverted image. Look at this case or look at this case. You guys agree? Real image, real image, real image. It could be magnified, inverted, whatever, but it's kind of the same. Now it means that from this question we can understand that if this is like our focal point and it is at 15 centimeters, so obviously 2f is going to be at 30. Do you guys understand that?
Yes.
So which row describes? So if the object was 40, that would mean it is beyond even 2f. So beyond 2f was basically smaller than its size, right? You guys remember that?
Yeah.
So real is correct, upright is not correct, diminished, yeah, it was correct. So it means this is wrong. And then going to 30. So it can't be virtual. So virtual answers are absolutely wrong. We don't want to check those. We're going to check C. So this is correct, incorrect because beyond 15. Oh, this could be correct because this is before F. This could be correct. So if we are left with 20 and 30. 20 and 10. So for 20, it has to be a real image because it's beyond that. And it's inverted. But is it diminished? It's not diminished, right? Why it is not diminished? Because if it is somewhere here, it would become larger image here from case 3. You remember this? So that has to be wrong. You get it?
Yes.
And then this one, because this is before F somewhere here, so it has to be virtual and upright. As we can see, it will form somewhere here. The last case, any large as well. So that would be the answer. So remembering the cases is important. So you guys need to revise that thoroughly, okay? Because these type of questions are difficult and they might, just get you trapped for a long time. So you shouldn't be taking that easy. Yes.
Can you explain this again?
Yes. So basically, you guys need to remember that if this is your F, this is lens, and this is 2F, right? So if you put here, anything after F, your image is going to be real. All these will give you a real image on the other side, and the images will also be like upside down. Do you understand? So my focal length was 15. So if I put it beyond 15, so that image will be upside down, but it says upright. That's why I cancelled it. Do you understand? Then
Yes.
if the object, like it was beyond 2F, why? It was at 2F, right? Because 2F is at 30, right? So if you put it 30, the image has to be the same size and it has to be real and has to be inverted. So enlarged and virtual was wrong, so that's why I cut it off. Do you understand?
Yes, sir.
Okay. And then for 20 here, 20 means it was beyond F. Now if it is beyond F and before 2F, so this is basically case 3 and it would create an image that is larger than before. But it says it is diminished, so I had to cancel this. Is it clear?
Yes, sir.
And the last one is like it is before F, so the image will be formed on the same side. It will be a virtual image and it will be upright, it will be enlarged. So all properties are correct, that's why I chose this. So you gotta basically go through all of them and remember that. Do you get it?
Yes.
Okay. Now going to a question like this, right? So it says shows a converging lens of image I, which is here as you can see, and then left of the lens, draw two rays to locate the object. So we have the image, but we got to do the object. So it means that we have to draw like in the inverse way. All right, what you're going to do is you're going to take one line and first of all make it go through. Oh crap, wait a second, it did not snap quickly. So I'm going to start from here and I'm going to go through the optical center like this. All right everyone, then what I'm going to do is the next line I'm going to go through the F till the lens like this. So I'm doing exactly the opposite of what we have done just now, and then I'm going to go straight from here. So you can use a ruler to do that. Obviously snap straight. It means the object would be somewhere here. Do you guys understand this?
Yes.
So what we've done, we have to just go in reverse. Alright, Zan, do you understand this?
Yes, sir.
So is this circle all the distances which are equal to the focal length. Obviously if this is principal foci, which means this is the focal length, this is also the focal length. So AB, no, sorry, AC and CB are the only ones which gives us that. Is it clear? Cool, right? So this is pretty simple. Just you need to do the construction. And okay, so then this says, okay, this question is a very simple. You can see the image. It is everything you can see inverted and stuff. So obviously you can do this, considering you have understood the first question that we've done. And if you still don't understand that, please do come back to me in the next class. Anyway, now going to the next one. This is exactly the same type of question, but here I'm just gonna do it with your permission, okay? And then one of those I will give you homework. So it says this is a full scale diagram, all right? And if it is a full scale, obviously my scale will be different because it's a digital diagram, but on the paper, on the exam paper, it would be the same, somewhat same. So you might have a different answer in your mark scheme for this, but the method is going to be the same, and it doesn't really matter if you do it correctly. So let's do it here. And then we're gonna go through F like this, and then one line straight from here and like this, okay? Now since you can see this is like before F, so obviously we need to extrapolate it, go backwards. You can use a ruler to do this. My answer might be a little bit different because I can't really do it as accurate as I want it to be, but it would be somewhat like here or something, okay? So this is where your image is going to form, because this is case 5, right? So this is my image, and now it says measure the length of the image. So what you do, you're gonna take your ruler, okay, and you are going to say, suppose if my object here is sort of somewhat, I think it is 0.7, right? So my image 0.7, my object is 0.7, and on the same scale the image I have formed is like 1 to 2.1, okay? So I'm going to do this. So my object was 0.7 centimeters and whatever my scale was, and the image was 2.1 centimeter. All right, so your answer might be a little bit different depending on how it is built, right, on your screen. So that would be 2.1 centimeters for me. It could be different for you. All right, is it clear? But on an actual exam, obviously all of you will have the same size of paper, you will have the same everything same, so it won't be stretched or something. So you will have everybody will have the same answer. You just need to remember this is case 5 because the object is placed before 2F, so remember that. Anyway, now what are the descriptions? Obviously this has to be a magnified one because it's magnified. It cannot be real, so it's virtual.
Still, I cannot hear.
Nobody can hear me? That's not fair. Hello? You can hear me?
Sir, we can hear you personally.
It's not very clear. Okay. Okay.
It
Something.
like cracked voice.
Okay, wait. Let me.
Okay.
I'm changing my internet. Probably my original internet has gone haywire. Okay. Can you guys hear me now? Can you guys hear me now? Can you guys hear me now?
Yes, yes, sir. Yes, sir.
Okay. All right. Interesting. So my internet has gone really, really bad. Okay. You can see the screen now?
Yes, sir.
And I hope it's not delayed or anything, right? Okay, so it's magnified, it is virtual, and obviously it is same way up as object, upside down compared to object, same way up as object. Do you guys understand that?
Yes, sir. So you have to label the image IG, right?
You do? I didn't know that. Okay, IJ. Happy?
So it's a question, yeah. No, like you have to put I in the top and J down.
Really? Who said that? Label the image IJ, that's it. You don't have to do anything like that. Okay? Yeah. Should I go to the next question then?
Yes.
Okay. So this is sort of a, again, different kind of question. It says green rays and glass block and then draw paths of three rays. Oh, ow. Okay, this is we're gonna do later. I'm gonna give this as homework. You will be able to do it, don't worry. But this is from the electromagnetic spectrum mix question. Anyway, so now this question, which is basically, let me see, you got to find the height, draw and label the image, and the distance at object of height 4 point place 7.5 centimeters from the lens, mark each of the foci. Okay, let me see if there's something, and you have the focal length as well. Generally these questions are easy. Okay, by the way, I'm gonna put this first and then we're gonna do. So it says light of air incident glass block, the light changes direction. Then the effect refraction. Causes change in speed. Change in speed of light when passing through another medium. Okay. So that's the effect, bending. Okay. Now for this one, they have given you the distances, fair enough, and they say your focal length is 3.5. So we're gonna start from here, and I don't know with 3.5. This is quite confusing for me as well. So I think if this is 7, which means you're here, 1, 2, 3, and 3.5. It means that some clever sorcery is this. What sorcery is this? Wait a second. So that's one box, and 2, 3, and this I think is 3.5. But the image they say mark the two principal foci at 3.5 centimeter. In each centimeter is this one. Oh, very nice. So small box is each centimeter. So we're gonna do 1, 2, 3, and I think 3.5 will be exactly here. You guys agree?
Yes, sir.
Okay. And then we also need to do this other thing, like 1, 2, 3, and 3.5, exactly in the middle. So you got principal foci labeled, and now we got one mark here. Then says an object O height 4.5 is placed this. Draw rays from the top of, locate the image, draw, label the image. That's pretty simple, as you now know. So you're gonna go straight first, and then we're gonna go towards F. So you can just use the ruler to do this. You don't need any other instrument. And then you gotta make it go through the optical center, and obviously wherever it meets, that is the point where the arrowhead is going to be, like this. You didn't understand. All right, fine. So that would be my image, and now it says determine the height of the image. So we can do it from the graph as well. You don't need ruler because this is not a full scale diagram. So this is like 1 centimeter, 2, 3, and so this is 3 centimeter, and this will be 3.2, 3.4, 3.6, 3.8. Okay, so you got to read it off from there. So it is 3.8 centimeters. Then say state and explain the image is real or virtual. Who can tell me?
It's real.
And why is it real? Because there.
Side of the lens.
Yeah, no, you're not gonna write that. You're gonna write.
It can be formed on a screen.
Yeah, it can be formed on the screen. It can be formed on the screen as the rays meet at a point. Do you guys agree? Understood? That's pretty good. Okay. Now, speaking of this, then we're gonna go forward. Okay, so this I'm gonna give you as homework because obviously this is a very similar question, and then obviously this one as well. But this is the question I want to do because this is a very, very important question. You guys can see the screen clearly. Interestingly, one of my screens is slow, one of it's faster. I don't know why. Why is this happening? But all right. Okay, is it clear, you guys?
Yes. Yes, mister.
Now for this one, now this question is a just you need to follow the instructions, but basically I'll tell you why it is important question. It says draw a straight line to represent ray from tip of arrowhead O to the tip of arrowhead I. Okay, so he has given us the instructions. We're gonna go from tip to tip like this, like that, right? Then it says draw a vertical dotted line to indicate the position of lens. Now you guys need to understand that when the ray can only go straight from the optical center, which means that this point, which is right here, I don't think I've drawn it perfectly correctly, so let me just redraw it, and then it should come really straight like that. And now you guys can see it basically is right here. So this is where the optical center is going to be, because from the optical center the rays do not bend. Do you guys understand that? So he's giving you the instructions, but you should also know if he hasn't given you any instructions on that. And then it says draw a second ray from the tip of the object to tip of image. The ray should pass through principal focus and label focus F. So obviously now we're going to go straight from here till this point, and then from this point we're going to make straight line to meet here. Oh, it created an, alright, never mind. So I'm going to erase this doesn't look nice. And if you see it crosses this point on the line, that means this is the principal focus. Do you understand?
Yes, sir.
And then say determine the focal length. This is 1 centimeter half box, so we're going to say this is 1 centimeter and this is 1.2, 1.4, 1.6, 1.8 and 2, 2.2 and 2.4. So it's going to be 2.4 centimeter. You can check it as well. The whole distance you got to take, okay? And then it says image is further from the lens than object from lens. Image I is described as enlarged and inverted. State and explain what the other characteristic. Do you know what is the other characteristic of this? You guys know. It's a real image, and because it forms, yes, forms on the screen as rays meet. Okay, is it clear? So this is the line you got to write, and he's going to ask you this again and again and again and again all the time. Anyway, so this sort of
Can you explain the first, second, and third part again?
okay. So what I've done is it says you got to draw a line from the tip to tip first. So I did that. Okay, do you understand? It crossed this point. It crossed this point. This means this is the optical center. Why do I know this? Because from the principal axis, if the line goes straight undeviated, and that is the point where the optical center is it clear?
Yes.
Then it said you got to make a dotted line. So obviously I had to put a dotted line vertically, and then it said you need to draw another ray that passes from tip to tip. So I drew it straight to the optical center, like the lens, not the optical center, lens, and then I bent it towards the image like this, and where it crossed, that is the point where it would bend through a focal point. You get it?
Yes, sir.
Cool. Now going to this one. All right, so this is kind of a question which is quite tricky in my view, and this question basically says that you got to find object O is placed in converging lens, but this time there are two rays going up. They're like one ray is going there, one is there, and that's pretty confusing because it's light on the line, right? So now it says, okay, so right now it says which statement is correct. Obviously, if one line goes from the optical center, you might see that basically none of these lines are going to meet with each other. So what kind of image should it be? A real image or a virtual image?
Virtual.
Because object and image are formed same, so we can keep that in mind, right? Okay, so if the virtual image is formed, then it says the image is diminished. Image is diminished, but I don't know about that. Image is inverted. It cannot be inverted. We have studied this, so that has to be wrong, 100% wrong. Whenever a virtual image forms, do you think it's diminished or it's enlarged through this lens?
Enlarged.
So this can't be the answer because this is case 5. The image is real, this can't be the answer. And then obviously the last one says the object O is closer to the lens than its principal focus. Do you think? Yes, because F would be object whenever virtual image is going to form is when the object is before F. So that has to be the right answer. Do you guys understand? So this is the way to basically attend to these questions, because obviously they will require some of your rote learning from what we've done. So then yeah, so this is a very similar question. I would like to give you this as homework, and you gotta do this. And then this is also a very similar question, so this as homework, this also as homework. So I've put so many questions for your practice this time, so many questions that you will be tired, but at the end of this whole worksheet you will be like, yes, we know this chapter for sure now. Okay, all of these are homeworks, all of these. So I put like they have similar, this is the one I just asked you to do. This is from the same thing, same concept. Try to do this, and if you don't do this, come back to me tomorrow. Okay, and then we're gonna move to, okay, we will move to this tomorrow. Okay, so we're just short of time now.
Sir,
Yes.
sir, can you please write the question number because I didn't print all the pages.
Oh no, Imal, that's not fair. Okay, so I'll just tell you the pages. Per page worksheet, and you gotta do it from, no, this is what we have done already. You gotta do from here. Oh yeah, here. So page 17 onwards. Yes,
Sir, it would be better if you could send the whole notes.
I have sent it
Sir, with your solution.
with the solutions. Okay, fine. All right, I'll do that. But it's not complete, so all right, I'll just send the ones that I've just done. Okay, fair enough. Okay, so I hope you guys understood everything, and while I'm doing this, you guys can just